and I'll be talking about doing experiments and doing them as best practice, but at the same time delivering mitigation and learning while doing it. I'm talking about a case study with tree hollows as part of a road project, but really it would be great for you to think about how you can apply the ideas and the principles for your projects. So tree hollows are a really critical resource for wildlife around the world. Within Australia, there's more than 350 different species that rely on tree hollows, many more around the globe. In Australia, we don't have any active animals that make hollows like woodpeckers, so it takes 100 to 150 years for a hollow to develop, particularly large ones like you see in the photo. And there's a global decline of large old trees around the world. This project is a new road and bridge connecting Victoria and New South Wales in the southeast of Australia. The road's been planned for 50 odd years, finally happened, just opened like 6 months ago. As part of the planning, we realised that there was going to be 316 large old trees that would be cleared to build the road and the bridges. And so a condition of approval was that we had to replace, for each of those large old trees, install one hollow for a particular species, and that was the condition of approval. And that's the road and bridge just finished and just opened for traffic 6 months ago. The standard approach to replacement hollows, and which Silvio mentioned this morning, lots and lots of studies around the world showing that nest boxes are used by a whole range of different species, but also recent research coming from Australia which found that the nest boxes are prone to falling apart quite quickly. They get too hot in summer, too cold in winter. We don't know whether they're suitable for the target species. They're used by invasive species. And so just because they're used doesn't mean it's actually a positive effect. So the regulator said, if you're going to install replacement hollows, you're not allowed to use nest boxes. The target species was squirrel glider, because they were the endangered species living in the area. They rely on these hollows. And so because of this stipulation about no nest boxes, the other options that we looked at were carved hollows, so actually with a chainsaw or a drill carving into a live tree, or putting up the logs. So when the trees were cut down for the road, we kept the hollow sections of logs, and then we can put those back up into the tree. We still don't know what the effects of carved hollows is on tree health, how long do they last, etc., etc. So we had to face a decision, and there was an opportunity. We could either do exactly what the regulator said, just put up 316 log boxes or 316 carved hollows and walk away. But we said, then we realised that we've been putting nest boxes up for 40 years, and only now are we saying, oh, maybe nest boxes aren't that good. So we said, why don't we do a bit of an experiment? We'll put up half of the replacement hollows will be carved hollows, half of them will be log boxes. We'll match them with a nest box and a natural hollow, and we'll see how they're used by species over time. So this is what a carved hollow looks like. Basically you cut an excavation in the tree, then you put this door in there. There's a couple of different ways of doing it, but this is the approach we took. The salvaged log hollows, standard nest box, and a natural hollow. We selected or installed these in clusters of 4. So each of these dots, green dots, represents one cluster of each of those 4 different hollow types. They were installed in December 2019, and every year we're going in and surveying use with a camera on the end of a pole. I'm not sure you can really see that there, but there's a pole at the camera right at the top of that pole. And we look inside the hollow, we see which species are using them, we assess the health of the tree and assess the condition of that hollow. And we've been doing that for 3 years already, so installed in 2019 and a survey in 2020, 2021 and 2022. There's another 2 years to go. The results, lots of use of the hollows by different species, and I'll go into some of the numbers in a moment, but these are what some of the photos look like. There's wear around the entrance hole, so that was evidence that animals were interested and had visited the hollows. That didn't actually demonstrate use, but the other three photos with eggs, chicks and glider, so that's a squirrel glider in the bottom corner there with the nest of eucalyptus leaves. They all demonstrate use. The target, the condition of approval was that, or the measure of success that the regulator said was that by year 3 or year 5, which was 3 years after construction, that 50% of the replacement hollows had to be used by wildlife. I don't know why 50% and not 55 or 60, but in any case, that was the target. So in 2020, fairly low levels of use, between about 5 and 20%, depending on the hollow type, were being used. In 2021, so this is cumulative use. So if a hollow was used in 1 year and then not used the next year, it was still counted as having been used during the study period. So the open bar represents the cumulative use in 2020 and 21. So the carved hollows, about 40% of those were being used, log hollows about 35%, nest boxes at around 50%. Natural hollows are much lower use rate of use that we could tell, and that's partly because in a nest box they're all the same size and the hole's in exactly the right spot so you can see easily in. The natural hollows are all sorts of weird shapes, different depths, so it's much harder to see. So I suspect the rate of use of natural hollows is actually higher than what we've recorded. And then the survey we did just a couple of months ago, the replacement hollows being carved hollows and log hollows above 50%. So the project has been successful in terms of the condition of approval. Natural hollows a bit less. And nest boxes, despite being considered inferior, they are the type of hollow that animals seem to prefer to use. And when I say animals, I'm talking about birds, the gliders and other vertebrates. We did have a few problems. So termites were getting into the carved hollows. So far, about 35 out of 158 have been packed with mud. So the termites bring up soil from the ground, they pack the hollow with mud to try and stop themselves from drying out. So then they become ineffective. They also chew the doors, so some of the doors have fallen off, and that's only a problem in the carved hollows. Only one tree collapsed because of the carved hollow, so we made the hole was too big and the tree couldn't support the hollow. Another one split just naturally, and it had a log hollow in it, so it's not that the failure of that tree was not because of the hollow type. And as I said before, the natural hollows are very difficult to inspect in the same objective way. We've also got a very subjective measure of tree health. So we're working with arborists, and arborists, they tend to not be very objective or quantifiable when they're assessing tree health. They just look at it, yep, that looks pretty good, or nah, that's, it could be better. So it's a really subjective measure. But at least we've got the same arborist from year after year, so it's a consistently vague measure. But none of the trees are showing any significant decline in tree health. So what are some of the things to consider about doing an experiment and learn while doing and deliver mitigation? So if there's ever significant uncertainty about whether something's effective, if the current solution's expensive and you want to try something different, if there's debate about what's best practice, and if the risk of failure is costly, and that might be a reputational risk, a financial cost, if there's project delay costs or environmental costs. They're all times when it might be appropriate to consider doing an experiment like this. And I think it's important to realise that many projects or many parts of projects are actually quite suitable for experimentation like this. Generally, as a construction person, so I'm now working with a consulting company, our job is to get stuff built and get it built on time and within budget. So there's little opportunity to learn while doing. But in fact, it just takes a conversation with the regulator or the sort of road agency and say, hey, we found this opportunity, and it might be in relation to the size of crossing structures. Can we design crossing structures for people and wildlife? What's the best strategy or best method to minimise noise or lighting impacts? Different approaches to revegetation, lighting, fence height and fence size and fence mesh size. They're quite small things that you can quite easily do experiments with. And so insert your project here. Some tips, I guess, perhaps first and foremost, you need a compelling and interesting problem or question to ask. If it's trivial, maybe don't worry about it. But if it's important, have a think about it. The project needs to have enough scope or scale to actually answer it well. If we were just putting up 10 nest boxes, there's so much variability that 10 nest boxes is not a big enough sample size. You need to be able to get an answer for the client. So for the road agency, they need to get an answer. It must be reliable. You need to meet conditions of approval. At the end of the day, that's the main criteria, is the condition of approval was set, we have to meet it. But ideally, we'd learn something and save some money, etc. It's good to have a supportive regulator. Research and monitoring sounds simple, but it's actually quite complicated at times, so get some help. And even though I said many projects are suitable, it's important to remember that not all projects are suitable. What's in it for the transportation agencies? You meet conditions of approval, there's evidence-based decision making, there's potential research and development tax savings, you build reputation, you become leaders, etc. There's a whole bunch of good reasons to think about it. So at the end of year 5, our replacement hollow program is working. We've reached that 50% target. There's no detectable impacts on tree health, and the information's already being used by the transport agency on other projects, and that's fantastic. And they're adopting this project as their own. So initially it was us pushing them and saying, let's do this. And now they're saying, hey, we've got this amazing project, we're doing this amazing work, and they're sort of claiming it as their own, which is fantastic. So thank you. I'll be happy to take questions.
So thank you, Rodney. The question is not about the squirrel, it's about if you have considered ecological consequences of nest box programs. For instance, at some places, a too high density of nest boxes leads to unnatural high densities of birds like tits in my country, and a severe decline of large butterflies, for instance.
Yes, we did think about that, and the reason we've got 316 replacement hollows is there were 316 large old trees being removed, and each of those large old trees could have anywhere from 5 to 20 different hollows. So there's still actually a net loss in the number of available hollows in the area that we did the project. So we haven't artificially increased the number. But it's a good question.
Hello, thanks, nice talk. I have a question, because you showed that your project is a 5 years long project, and at least in birds, occupation rate increases very fast during the first years, but then decreases due to, it's supposed that birds avoid reusing to reduce parasitism and these kind of things. And I don't know if you consider to expand that in 5 years, that is a long period, beyond.
Yes.
Thanks.
So yes, I'd like the project to continue, and I don't quite understand why, but we have offered this project to postgraduate students. It's a really well set up experiment, but there's not been any students showing interest. So that's to extend it, we would need to get a student involved to continue on. So if there's any students that want to come to Australia to work on a great project, come and let me know.
We have time for one last question.
Any questions online?
No.
Okay. Marika. Wait.
Not a question, but a comment. You told us that an old growth forest was fragmented. And my question is not only to you, but in all these cases, why do we avoid that impact? Because you looked for 1 or 2 species, but if you know, old forests have much more than these 2 species. Yes. And it's a huge impact, and we cannot minimize or compensate that. Mm-hmm. And for the future, I think we have to avoid such impacts, and then we are not in need to develop such methods.
Agree entirely. Mm-hmm. We avoided what we could on this particular project, but at the end, there's a 2,400 kilometre strip of trees along the river, so at some point we had to cut through the forest for this particular bridge, unfortunately. But yes, agree wholeheartedly, we should be avoiding much more than we are. Mm-hmm.